Welcome to 3.5, the last section we're going to do in Chapter 3. This is on exponential growth and decay and modeling data. So our essential question is, in what elements of life might we see exponential decay? Exponential growth and decay models. So if k is greater than 0, the function models the amount or size of growing entity. And if k is less than 0, the function models the amount or size of decaying entity. So if it's growing, it's going up. If it's decaying, it's going down, but it'll never hit 0. It'll get super close, and you can barely tell the difference. So, an application question. In 2000, the population of Africa was 807 million. And by 2011, it had grown to 1,052 million. Use the exponential growth model, in which t is the number of years after 2000, to find the exponential growth function that models the data. So that means our new amount is a. We don't need to add the million part in, that's fine. And the a sub 0 is your original, which is 807. And you have your e, your k you're looking for, and the number of years is your 11. So now we're just going to solve this. So divide your 1052 by 807. So now we're going to do the same thing we've done before, and you're going to take the natural log of both sides. Remember, you take the natural log, generally when you have an e, every time you have an e, you want to take your natural log, because they kind of cancel each other out. So now you have your ln 1052 over 807 equals k times 11. So now you're just going to divide both sides by 11, so you should have k equals ln 1052 over 807, all divided by 11. This is going to give you k about 0.024. So the equation, or the k that you now have, is a, the original a, e, 0.024t. So that is the new growth function for that part. So that's your equation with your k in it. So this is the same problem. Now that we've solved for k, we can use it to answer the other questions that they have. So you can ask, after how many years, how much will it be? Or you can ask, if you have this many, how long will it take to get there? So this question says, by which year will Africa's population reach 200 million, or 2,000 million, or 2 billion? So this way we're going to put in 2,000. And we're going to fill in the rest of the equation. And we're going to solve for t. So now we got here, we're just going to divide both sides by our 0.024. If you were to simplify this, t is about 38. So remember, you're going from 2,000, so about by 2038, the population will equal 2 billion. So this one talks about half-life. So the half-life of strontium-90 is 28 years, meaning that after 28 years, a given amount of substance will decay to half the original amount. So find the exponential decay model for strontium-90. So if we know it's a half-life, so it's going to be your original divided by 2. So you have 1/2 equals 1. In this case it says 28 years, so our time is 28. So you have ln 1/2 equals k times 28. So if you were to solve that, you'd get about negative 0.0248. So your model is A equals original A, E, negative 0.0248 T. So this is your exponential decay model for that element. Now in the next question, it's going to ask you about amounts. So we found the exponential decay model to be that if there was originally 60 grams, how long will it take the strontium-90 to decay to a level of 10 grams? So we want our new one to be 10. Our original is 60. So if I were to divide both sides by 60 and simplify, I have 1/6 equals E. Take the ln on both sides. And that will give you about 72. So that means after 72 years, it will decay that much. So logistics growth model, the mathematical model for limited logistics growth, is given by that equation, where A, B, and C are constants, B and C are both greater than 0. So in Learning Theory Project, psychologists discovered that f of t equals 0.8 over 1 plus e to the negative 2t is a model for describing the proportion of correct responses, ft, after t trials. Find the proportion of correct responses prior to learning the trials taking place. So that means your original. So that means your f is f of 0 since that's your original, so you're going to plug in 0 in for your t. So this would be e to the 0, which is 1. So your 0.4. So that's your original, it's 0. Next one wants to know after 10 learning trials. So f of t is now going to be f of 10. Once you solve that, you get about 0.7. So after 10 trials, 0.7 correct. So make sure you complete the questions below and watch the next video. Next class, or next video, we'll discuss Newton's law of cooling, choosing an appropriate model for data, and expressing an exponential model in base E.